we're going to go back to what we were doing on Thursday, way back before we learned any of our rules. We were expanding and condensing. When we had a fraction with exponents in the top and in the bottom, we had to expand first. So I would take something like 4 to the 5th and write that 4 out 5 times. 3 times in the bottom. And then our trick for when we were condensing is if I had something in the top and in the bottom, they cancel each other out. So a 4 in the top cancels out with a 4 in the bottom. A 4 in the top cancels out with a 4 in the bottom. A 4 in the top cancels out with a 4 in the bottom. What's left over is 4 times 4, or 4 squared, and 16. So think about that. What do we think a real quick, easy rule for doing that in our heads is? We're going to subtract those exponents. So 4 to the 5th over 4 to the 3rd, we can rewrite that as 4 to the 5 minus 3 power, which aka 4 squared, or 16. So when dividing powers with the same base, we are subtracting the exponents. That's called our quotient rule. So if I look at something like example 1, d to the 8th over d to the 3rd, what can I rewrite that as? D to the 5th, or d to the 8 minus 3, erase, which is d to the 5th. Questions on that? Now, the tricky part is that we're going to have to work with negatives and stuff like this. We are always going to subtract the top minus the bottom, and everything will move up to the top. So if I have g to the negative 5th over g to the negative 6th, let's rewrite that as g to the negative 5th minus a negative 6. So 2 negatives makes a positive, right? So that's really like g to the negative 5th plus 6, which is a g to the positive 1. That's simplified. In example 3, we start making things even more tricky because now we're looking at multiple bases. The 6 over 9, that's just going to stay as it is for right now. We'll take care of it later. And then I'm going to first take a look at the x's. Again, I'm going to do the subtraction, and I'm going to bring it to the top. So x to the 3rd minus 1, 3 minus 1 is x to the 2nd. And then for the y's, y to the negative 2nd minus 4 is the same thing as y to the negative 6th power. What do I now need to do to simplify this? Now that everything's up at the top. I see this negative exponent right here, and I'm going to bring it down to the bottom because the negative exponent always goes down to the bottom. So let's rewrite this. 6 over 9, x squared is in the top, y to the 6th is now in the bottom. Is this all the way simplified? What can I still do to it? I can simplify those numbers like they're a fraction. So 6 over 9 is the same thing as 2 over 3. Everything else stays the exact same. Questions on that? I'm going to show you a little trick here. I'm going to zoom in. We see the x's and the y's, right? For the x's, I have x to the 3rd and x to the 1st. If I compare the exponents, 3 is bigger than 1. Wherever the larger exponent is where your variable should end up in your final answer. So the 3 is bigger here. That means my x in my final answer was on the top. For the y's, the 4 is bigger than the negative 2, so the y's should end up in the bottom, where the bigger exponent is, in our final answer, which it does right here. Does everybody see that trick? So if I take a look at example 7, or sorry, not example 7, example 4, where are the V's going to end up in my final answer? In the top. Where are the W's going to end up in my final answer? In the bottom. That's a good way we can check. So let's do that subtraction. When we do the subtraction, everything goes to the top. So v to the 5th minus 2 is v to the 3rd. W to the 1st minus 6 is w to the negative 5th. And hey, look, it checks out. That w has a negative exponent. It's going to go down to the bottom. We rewrite this as v to the 3rd over w to the 5th. Exactly how we said v would be in the top, w would end up in the bottom. Does that make sense? Amazing. All right, lots going on here. Let's start with rewriting the 8 over 4. What happens to these c's? I have a c to the 4th up in the top and a c to the 4th down at the bottom. What do we think is going to happen to those? Jason, 1. They're going to turn into 1. C to the 4th minus 4 is 0. Anything to the 0th power is 1. This also follows our rule where if I have something in the top and the same thing in the bottom, they're just going to cancel each other out. So those c's cancel out. Then I have d to the negative 2nd minus negative 3. So negative 2 plus 3 is the same thing as d to the 1st. And then I need to simplify this one more time. 8 over 4 can simplify to what? 2. So we can rewrite this as just 2d. Any questions on that one? All right. Help me out here. I'm going to leave 10 over 6 for right now. Where are the r's going to go? Are they bigger on the top or on the bottom? They're bigger on the bottom, right? R to the 1st is bigger than R to the negative 3rd. So we can start skipping steps once we feel pretty good about this. If I have R to the negative 3rd minus 1, that's R to the negative 4th. So in the bottom, it should say R to the positive 4th power. Look at the t's. Are the t's going to end up in the top or the bottom? In the bottom. I do t to the 7th minus t to the 10th. That's a negative 3. So I'm going to have t to the positive 3rd power in the bottom. Do you see how I was able to skip a couple steps there? Okay. Simplify 10 over 6. 10 over 6 simplifies to 5/3. R to the 4th, t to the 3rd. Any questions on that part before I change it up on you? Flip it over. I'm going to combine the rule we're doing today with the rule that we talked about yesterday. Do you remember yesterday how we raised an exponent to another exponent and we had to make sure that we distributed that exponent? We do the same thing if it's in a fraction. So I have that entire fraction raised to the 2nd power, which means I'm going to distribute this squared to everything on the inside. To the 4, so 4 to the 2nd power. To the 5, multiply those exponents, that's y to the 10th power. And then also to the x, which is x to the 6th power. Which simplifies out to 16 y to the 10th over x to the 6th. Good on that? So our rule, when raising a quotient to a power, distribute the exponent outside to every exponent on the inside. I'm going to show you 2 ways that we can take care of this. So when I've got a bunch of stuff happening in here, like in example 7, I'm going to take that exponent and I'm going to distribute it. Negative 3 goes to the y to the 2nd, y to the negative 6th. It goes to the 2 to the negative 3rd, and it goes to the z. Remember, we are multiplying these exponents. So negative 2 times negative 3, positive 6. Am I done? I got a lot to simplify here. I have to do y to the negative 6. That's a negative exponent. So it's going to move to the bottom. 2 to the negative third, also a negative exponent. It's going to move to the top. So let's do that first. 2 to the third, y to the 6th, z to the 6th. And then I got one more step because I got to take that 2 to the third and I got to make it an 8. And now I'm done. Good? James? Because this was a 2 to the negative third, so I had to move the 2 to the third to the top. Okay, let's do that exact same process again. I'm going to distribute the 2 to every single piece on the inside here. So for the top, let's do this in different colors. I want 2 to the second power. I want a to the second power. B, multiply those exponents, b to the 12th power. Over. Let's do everything on the bottom. 6 to the second power. A, negative 3 times 2, negative 6th power, and then b to the second power. Now I'm going back to regular quotient rule where I'm simplifying all of these things. I have 2 squared gives me 4. 6 squared gives me 36. Are the A's going to end up on the top or the bottom? A's, top or bottom? They should go on the top, right? 2 is bigger than negative 6. So 2 minus negative 6 is 8. Because I'm subtracting a negative. That's like adding. So that's A to the 8th power in the top. And then B's, are those going to go on the top or the bottom? Also should go on the top. 12 is bigger than 2. 12 minus 2 is B to the 10th. I can simplify one more step. 4 over 36 is the same as 1 over 9. Anytime I have a 1, I don't need to rewrite that, so I can just have this as A to the 8th, B to the 10th, over 9. Any questions on that? Read.
No questions on that.
2 more. Are you not looking at the same place on your paper? Okay, so that is one way we can do these, where we distribute first and then we simplify. But we can also simplify first and then distribute. It's kind of whatever you like the best. So if I take a look at example 9, I see that this whole thing is raised to the 5th power. I'm going to rewrite that part. And let's just simplify what's on the inside. What can I simplify that inside piece to? Give me the whole thing. Yeah, we can subtract the ends. So is the end going to go in the top or the bottom? It's going to go in the bottom. What's going to be left in the top? Nothing, so we write a 1. We have that M, and then how many ends in the bottom? 2. N to the first minus 3 would be a 2. Okay, so now that inside part is simplified, it's a little bit easier to do my distributing. I'm going to distribute this 5 to everything in here. So that's 1 to the 5th power is 1, M to the 5th power, N to the 10th power. Not too bad. Let's do another one like that. So in example 10, let's simplify this first. What can I do with those A's? They're going to go in the bottom because A to the 1st is bigger than A to the 5th. So let's rewrite this guy. 3 over 2 here. And then it's going to be A to the what? A to the 6th power. Negative 5 minus 1. A to the 6th power. Okay, then my distribution should be pretty easy here. 3 to the negative 2nd, 2 to the negative 2nd, A to the negative 12th. Ooh, hello. I'm going to run out of room here. 3 to the negative second is going to go down to the bottom because that's a negative. These negatives are both going to go up to the top. So we can rewrite this as 2 to the positive second a to the 12th over 3 to the positive second. And then one more simplifying step, I think. Maybe there's one more. 4 over 9a to the 12th. And we can't simplify that any further, so we're done. Any questions? I'm not going to move it. Are we good? All right.